Hello, welcome to this video where I will explain to the subject of rotational equilibrium in statics and its application for engineer mechanic, rotational balance and formulas and equation examples and exercise. And extended body is said to be in rotational equilibrium when to the sum of torques acting on index zero. This does not mean that to the object is necessary a rest, but rather that there is not a tendency to change its state of motion of another. An object moving with constant speed is moving along a straight line, and we can consider it to be in rotational equilibrium. New objects rotate because there are forces acting on them in such a way to the rotation results. The ability of a force, the production and rotation. Torque depends not only on the intensity of the force, but also on where is applied. We recognize this immediately when opening and close door. The force is never applied close the hands, but away from them, which is why the handle is placed as far away possible on the opposite side of the door. Through the hang space, the axis of rotation of the door by insisting on pushing it very close to the hangings. It takes a lot of effort for the door to move it even a little. Yes. The first term is rotational equilibrium condition. It's the sum of moments of torques acting of a body calculated with respect to any axis must be zero. The object in question must be extended since particulars by definition only have traditional equilibrium. There can be forces applied to the body rotational equilibrium side excites along the forces to no rotation it. There can also become movements even accelerate but always along a straight line. Since not alone forces cause the appearance of torques. There appear when the force do not act along the same line of action. The second term is the torque or moment of a force. Yes, is denoted for the Greek letter because it's a vector, and to with distinct it from its magnitude or modulus, which is a scalar. It depends on the applied force P on the vector R that is directed from the axis of the rotation O to the point of application of the force, and finally on the angle between these two vectors. The tree is a director and sense of torque. As the torque results, the cross product between the force and position vectors, and these are in the plane of the wave. The torque must be acted perpendicular to said plane that is directed towards the reader or towards the inside to the range page. By convention, torque is positive if a product's contour clockwise rotation and negative if it produces clockwise rotation. The director and signs of the resulting torque is easy determined using the right-hand rule slope volume. And the mechanic applications is, for example, in the figure is a wrench with which is attended to the torque now under clockwise size. For this is tested with to the force F and FB. FA is the close to O and has a shorter lever to the vector RA. So it does not produce as much torque as the force FB, which has same magnitude but has a large vector RB. And that is why if you want to the torque not clockwise size, you have to apply the force in the opposite director as shown in the figure. Thank you. It's for much of the video. No more.